Hey everybody. Today I thought I would talk about fuel gauges and fuel sending units. It seems like a lot of people get overly confused with them. It's a pretty basic system and it's a fairly universal system. The way that a Ford truck works is the way that a Chevrolet truck works, which is the same as the way a lot of boats work, and everything in between. Hot rods, pretty much everything from probably the 50s on up to today has very similar properties. So I thought I'd give you a quick overview of how they work. And with that, hopefully you get some theory and understanding of how they work so you can diagnose your own problems. Uh, start with, I'll show a few basic fuel gauges. These are just things I had laying around. This is a 67 to 72 GM truck. That is actually out of a boat. And then this was a early 80s Jeep CJ. And the first part I really want to get you to notice is there's three prongs on the back of all of them. And this kind of holds true for everything throughout the hot rod world, the classic car world. Like I said, boats, off-road vehicles, they're all kind of the same. You're going to have a positive, a negative, and a sensor. So the positive is a key-on type connection. When you have the key turned on, you're going to have power. Negative is a ground, chassis ground, whatever you want to think of it as. And then the sensor. The sensor is actually another kind of ground. We'll get into that in a little bit. But the boat, you have ignition, G for ground, and then sensor. I don't know if you can quite get that in there. Maybe not. Maybe I can focus on it. So yeah, ignition, ground, sensor. The back of the Jeep is not really labeled that way because it really isn't meant to be taken apart probably, but same idea, key on, sensor, and a chassis ground. And then of course you have the sending unit itself. This is actually out of a slightly newer Jeep. I think this is out of a early 90s Jeep. You have your float and it's in the tank. It's going up and down with the level of fuel. Here would be an electric fuel pump would actually be right there, but we're not worried about that for the moment. You got two wires coming off of this. You have the sensor wire, and then you have a ground. And all this apparatus is doing is going up and down with a level of fuel. And if you notice up here, you have this blue wire, goes all the way around and ends up here. The ground is connected to the body. It's connected through all this. And that's what two of your wires are here. The ground is kind of shared between the fuel pump and the sensor, which we're not real worried about the pump itself. The power for it, and then the sensor wire. So I'll show you a little bit of animation that might make it a little clearer, and then we'll come back to this. What it basically boils down to is inside of the sending unit is what's called a variable resistor or a potentiometer. Those two things, they mean the same thing. Let's show a little quick example that might make some sense. As you saw, the sending unit goes up and down. Well, what it's doing is it's varying resistance. So I have a bag here of, I think they're 20,000, yeah, they're 20,000 K resistors. And we all pretty much know what a resistor looks like, but it just slows down or inhibits the movement of electricity in simple terms. So when I go either side of this on my meter, you can see that it's going to balance out and show basically 20,000 ohms, 20 K ohms. It's a little off, but that's the nature of it. So there's something called a potentiometer or a variable resistor. And I'll see if I can get this in the picture. The digital meters that we all use nowadays don't always show the best representation. But if I can get this connected, maybe. You'll see a number there on my screen, 36 kilo ohms. So as I turn this knob, see how it's changing the resistance? That variable resistor is virtually exactly what's going on right here. So let's go over here. We have an older like a sweeping dial multimeter. This is probably 30, 40 years old. I think it was actually my grandfather's. But at any rate, I can connect there, and I can connect here, and look at that needle. That sure does look familiar to a fuel gauge, does it not? As that sweeps through, it's just measuring the resistance through this potentiometer. Again, same as this would do. So if I can give you a better visual, imagine this right here, floating up and down. This is just a float. Imagine it going up and down and your fuel gauge moving. So I can even recreate the whole system here just to kind of put it in perspective. So what I'll do now is I'll show you a basic circuit of how the fuel gauge itself works. Like I said, this is a 67 to 72 style Chevrolet truck, and we'll start with the basic connection. You got power and ground, and you see the gauge it's going to max out over here because there's no resistance. It's on basically. So if we want to provide a signal ground, which is how this gauge works, we'll go across this variable resistor. Get it clamped on there. And when I hook to the back here, the signal, if you can see that, it's upside down, but signal. So this potentiometer is not really in the range of what the sending unit would be for this particular gauge, but you can see I can move this and it starts going back and forth. And that's basically all that's happening. Again, you can envision a float being attached to this and moving up and down in your fuel tank, and that's really all that's going on. So when people are having trouble with their gauges, there's basically only three components: the gauge itself, and they do go out; let's call it the sending unit, the variable resistor, potentiometer, or the wiring and connections in between. There's really only three parts to it. You again have to have your key on power, your constant chassis ground or negative ground of the battery, and then the signal. One of the most important aspects of the fuel gauge system is the resistance range, or the ohm range of the sending unit itself, and it has to correspond to the gauge. So you can see this chart here. You could pause it and come back to it. Do your own research depending on your application, but most of the major applications are here in front of us. You can see that 0 ohms in some of the GM stuff corresponded to empty, whereas 30 ohms or 90 ohms corresponded to full. So if you have an ohm meter on your resisted signal that goes from the sending unit to the gauge, you should see it sweep through these range depending on which sending unit you have. Again, you have to match them up. Say, for example, you had a 72 Dodge Mopar sending unit, and you were trying to match it to a 72 GM gauge. I don't know why you'd want to do it, but let's say you were. That 72 Dodge float, if it's down empty, it's going to be putting up back a resisted signal range of about 73 ohms. Well, your GM gauge is going to interpret that as almost full. You know, if 90 ohms is full, then 72 is maybe 3/4. As that Dodge fuel tank and sending unit got full of fuel and the float started to rise, it's going to go down to a lower ohm range, about 10 ohms. Well, that GM gauge is going to interpret that as almost empty. So not only is the numerical range important, but the polarity almost is the way of thinking about it. It has to go from high to low or low to high and correspond from gauge to sender. Maybe you're doing a chassis swap, or maybe you're building a rat rod and the fuel tank's from something and the gauge is from something else. It's critical to match them up. Same way with aftermarket gauges. If you trying to buy a replacement gauge for your new dash, and you have a certain original fuel tank and sending unit, you have to match this stuff up. Otherwise, it's not going to work. You might start getting readings that are way off the chart. way below E or way above full, or they're inverted or whatever. You see down at the bottom where it says Dakota Digital and programmable. A lot of the aftermarket gauges, more and more every day, are getting where you can program them to various ohm ranges. For instance, say you have the existing stock fuel tank and sending unit in your classic vehicle of whatever sort. You can get an aftermarket gauge that you can choose or program it to work accordingly, and that's great. The more we get of those, the easier this is. But I just want to make sure that everyone understands that that varying resistance signal is a very defined range depending on the application that you're working with. And if you get outside of that range or something doesn't line up, you're going to have problems. So we're about to talk about a kind of a general overview of the different components of this system. That they all pretty much boil down to this same set of components. The wiring might be different from A to B, but it's going to be the same basic pieces. You'll have your fuel tank, a battery, hopefully a fuse, an ignition switch, and a fuel gauge. So if you start with the battery, and let's think of it in terms of wiring, you're going to have a wire going from your battery to your fuse, and from your fuse to the ignition switch, from the ignition switch to the fuel gauge itself. So when you turn on that key and you have it in the run position, you're going to have 12 positive volts to the gauge. That's one part to check. The other side of it, of course, you got to have a ground. This might be a chassis ground, it might be a direct wire, but one way or the other, you're going to have a ground connection on that sending unit at the tank. You're also going to have a ground go to the gauge itself. Remember, it's got to have power and ground for it to properly work. From there, you have what we would consider the actual fuel sending unit wire. Now, it is a resisted ground. If you look at our sending unit, we're getting this green wire that's going to come off of it, and that represents our resisted ground signal to the gauge. That's the one I was just mentioning that might be 0 to 30 ohms, 0 to 90 ohms. You can get your ohm meter out and check this wire to ground, and it will have a varying resistance on it. So you have your three major components: key on, negative ground, and a resisted ground signal. So let's say we're doing a 0 to 90 ohm GM gauge. We're all the way full in the tank. That green wire has approximately 90 ohms of resistance on it. As the float comes down, that resistance is going to go to approximately 75. It's going to be a sweeping range, but your gauge will then be looking at 75, now 60. As it moves down, the resistance will drop. Approximately half a tank is going to be approximately 45 ohms. Still going down, 30 ohms, getting closer to E. 15 ohms, maybe you got an eighth of a tank left. And then down all the way to 0 ohms, no resistance, you'll see your gauge go to empty. And again, this is just an example of your 0 to 90 ohm GM style, but they all follow the same principle. They just simply might have a different value depending on what your sending unit is. So when it comes to actually using the ohm meter, mine has a omega symbol there for resistance. When you touch the leads together, the meter goes to 0. That's no resistance, 0 ohms. It's a good connection across the two terminals. When you take them apart, it shows OL, meaning open line, no connection at all. So once I finally get these leads connected to the sending unit terminals, it's pretty simple. There's two leads and there's two terminals across the sending unit. And you can see as I move the sending unit up and down, my ohm reading will vary on the meter. That's empty, which is basically 0 ohms. And when I go up to full, you'll see that's basically 90 ohms. As it sweeps through, it's just going to be a varying resistance on the digital meter. Let's go ahead and put it all together, and we can use some of the actual factory components. This is basically going to be a setup that represents that diagram animation that I showed a few minutes ago. It's a little messy with the leads, but it should make sense. We have a ground wire going to the negative side of the fuel gauge, and we also have another negative wire going from the battery to the housing of the sending unit. So they're both grounded. Then we'll use a green jumper, and it's going to go from the other side of the sending unit to the sending unit side of the gauge. Sensor, signal, sending unit. You can think of it whatever you want. Then, of course, we're going to add 12-volt positive representing a key on source. We'll have all three of our leads: power, ground, and signal. I mentioned before this is actually an early 90s Jeep sending unit put together with an early 70s GM gauge, but they happen to be the same ohm range. 0 is empty, about 90 ohms is full, and you can see as I move the float, the gauge is going to move. There's one more thing to note. There is some built-in dampening. I won't go into the circuitry of that, but most of these gauges have some means of dampening their movement. Otherwise, they would just bounce around with your fuel. As you see, it's kind of delayed, and that's normal. If it wasn't that way, as you bounced around on the road or off-road or whatever, and the fuel sloshed, your needle would just be jumping back and forth rapidly. And if yours does do that, it's a gauge issue. But there you go. That kind of shows the basic circuitry and the wiring. Hopefully it makes some sense to you. If you have any questions, leave a comment below. Thanks for watching.